Hello again, welcome back. We are continuing with our perspective drawing series and focusing on 2-point perspective. We are in part 4 and we're going to focus on circles, curves, round objects, and spheres, okay? And how to draw all those things in perspective, such that you can do things like cones and cylinders and pipes and holes and openings and doorways and ovals and things like that. All right, so yeah, just starting off with this shot of the last thing we did from our last video, which was just basically finish up the intro to 2-point perspective, drawing boxes all over the place, below the horizon line, straddling the horizon line, on the horizon line, and above. Okay, and again, just to recap, just like we saw in 3-point perspective, the same rules apply. When the box is below, you only see the top of the box. When the box is straddling, you do not see the top and bottom, you only see the sides. When the box is directly on, again, you don't see the top and bottom, you just see the sides. And then when the box is above the horizon line, you only see the bottom and at least one of the sides. Okay, in this case, we see 2 of them. So regardless of what position they're in, because these are slightly different, I did the black and whites slightly different, but you can see that the rule applies across the board. Okay, so it does the same thing in 3-point perspective, does the same thing here in 2-point perspective, and you'll see it do the exact same thing in 1-point perspective when we get to that. All right, so I've gone ahead and made copies of the black and white drawing. Made a few copies in case I mess up any one, but I think we should be able to get through. We should be able to get through this in one shot. Let me zoom in a little bit. There we go. Okay, so that's what we're going to be working on. Let me get a separate sheet of paper just to do a quick overview of what we will be dealing with, what we're talking about here in terms of circles, in terms of curves, ellipses, all that kind of stuff. And then depending on how long this runs, this might be a 2-part video, okay? I'm gonna try and keep it all in one, but it might be necessary to split this up into two shorter videos. Okay, so let's remember from our 3-point perspective videos when I talked about, when I got on this topic, when you have a perfect square, okay, I'm hand drawing it, but when you have a perfect square like that, to get the center of the square, you connect the 2 corners, that'll be the center, and then if you strike a horizontal line through that center and a vertical line through that center, you get these reference points. Okay, the more reference points you have in a construction, the more accurate your construction will be across the board, or for the most part. And then this will be your radius. You take a compass and basically you can draw a perfect circle. This one is not perfect because it's by hand, but you can draw a perfect circle within that box, okay? And you can have fun if you want to make, we take the radius from the center to the side. If you want to take the radius from the center to the corner, you'll get an outer circle which should cut these outer corners like that. Which should cut or intersect these corners. That's what should happen, okay? Now, when we put that square in perspective, like so, you do the exact same thing. All right, you just connect the corners, and then and in this case, since we're doing 2-point perspective, we don't have to worry about the 3rd vanishing point. You just strike a perpendicular line straight through the center like that. This will be dependent on your vanishing point. In this case, the vanishing point to my right over here to get that point. And then what you will get is an oval or an elliptical shaped object. You can't get a circle, so you're going to get an ellipse like that. And again, with the ellipse, when you're working in perspective, now again, for something like this is a flat circle, so this is what you're going to get. Okay, this is what you're going to use. So if you've drawn out a square and you've measured it out, and one of these matches it, you can just pretty much plug that in there and draw it in. If not, because they don't always match, you can always just, again, like I said, just use a compass from the center to the side, get that radius, or the center to the corner, and draw your perfect circle, right? When you're dealing with an ellipse, you also have ellipse templates, but again, when dealing with, let me put this here, yeah. When dealing with an ellipse, again, this is a perfectly symmetrical ellipse. So basically you're looking at the ellipse head straight on, right? Directly looking at it. So it's going to be symmetrical all the way through. When you put this ellipse in perspective, it's not going to be symmetrical. So you can't just take this and then plug this into your perspective drawing. It'll look really wonky and weird. So you basically have to set up your perspective rectangle or square, and then go in there and map out, plot out your ellipse. And then once you've got it plotted out, do a little freehand version of it, and then take your French curves and smooth everything out. Okay, and what you'll have to do is find the curves that match up perfectly with the different parts of your ellipse, and basically construct it together and make everything look continuous. All right, so there's that. So I've gotten a little ahead of the game. Well, yeah, a little bit ahead, talking about ellipses. So let's say you have let me do the two of these all at once. Okay, so let's say you have a long rectangle like this, and it has two squares. It's supposed to be a perfect square. It's not, but let's pretend these are perfect squares. Again, you'll do the same thing here. And here. And since they're existing within the exact same square, since they're existing within the exact same symmetrical rectangle, let me say that again. Since they're existing within the same rectangle, let me take out the symmetrical part and not confuse anybody. When you do this construction, this horizontal line should match up with that middle section. So you get the middle in the same way, and then it should match up properly if your rectangle is drawn accurately. And then you go with your compass and draw your circle in there. Again, this is not a perfect circle because that's not a perfect square. Okay, and then once you get that, you can connect the edges, the tangents of the edges, and you get this oval, which has these two straight sides, right? And that's a useful shape in certain situations, depending on what you're going for. All right, so we have the same rectangle here, pretty much the same as this, but instead of subdividing it this way, we're using the whole thing. And basically to get the center, again, connect those corners. I'm doing it by hand, so it's a little messy. Connect those corners, and then vertical line through the center, horizontal line through the center. This is the center of this side. This is the center point of this side. It's all symmetrical, nice and symmetrical. And then you work in your curves at those extreme ends and sketch in your ellipse. Now this ellipse right here, because it's flat, because it's head on, is more in line with what's going on here. Okay, so this is a symmetrical ellipse, perfectly symmetrical. The minute you take this and you put it in perspective, like that, and then you take this one and you place that in perspective, you get the subdivision, like that. Put this away. You'll do the exact same thing here. With 2-point perspective, you're just dealing with a straight horizontal line through the center, and then this, vertical line through the center, this perpendicular line, and then when dealing with a horizontal, again, you will use the vanishing point. You'll connect this to the vanishing point through the center, and it should match up perfectly if you're doing your construction correctly, right? And then you go in and sketch in that ellipse, lightly sketch it in, and then use the French curves or your flexible curves to map out the oval that will be in there, and then complete the rest of that construction. So get something like that. And that, okay? To get that shape. But then with this now in perspective, again, connect those corners to get the center of this rectangle in perspective. So in perspective, that's the center. Strike a vertical line straight through that center, and then connect this horizontal line through the center to your vanishing point. Your right vanishing point in this case, if the box is this way and these lines are dependent on the second vanishing point, then that's what you will use to get the line in the middle here. Okay, so once you get that, you've got all your points, your reference points. And then from experience, you'll know whereabouts the curve will cut on this diagonal line. And it's never usually like right in the middle, but after doing a few of these, you'll get a feel for it, because it varies a little bit depending on the kind of shape that each person draws, which will be different from person to person. But it's never going to be like way over here. It'll probably be within this space here. So you sketch out your ellipse, and then you come with your French curves or whatever tool you're using to smooth this out and make it a nice continuous curve. Okay, so I think what I'll do is I'm going to mention one more thing in this example. I'll cut it off here, and then in the next part I'll do the actual construction. So the next thing I want to mention is the sphere. Like, how do I draw a ball or a sphere in perspective? Okay, and let's take a quick look at that real quick. And the example I'll give is, okay, let's say I have let's say I have a couple of boxes. So at this point we've all gotten, used to drawing boxes in perspective. So let's say I have this box, right? So any position I turn this box in three-dimensional space or in perspective, it's gonna look very different. So if I have it in this position, that's very different from when I have it in this position, different position, different position, different position. Like everywhere I turn this box, it looks different, completely different, all right? So the positioning of this box, however I position it in my perspective drawing, it's gonna look different every single time, okay? Same thing, and here's another box, another example of this box. Okay, I feel like I'm doing product placement now when I'm trying not to, but yeah, just the same thing. I mean, it's different every time. Any slight movement I make, it's a completely different configuration, completely different composition, okay? All right, well, let's look at a ball, okay? So I'm gonna turn this ball and move it around. And basically what we have is a perfect circle. Let me even be so extreme. Let me put the ball down right about here. It wants to roll on me, so I'm gonna have to hold it. And if I take my circle template, you can see that, you know, it's a perfect circle, right? If I move this ball around, if I move it here, if I turn it, anywhere I place this ball, way over here, way over here, way over here, down here, I turn it, it's still a perfect circle, okay? So that is the great thing about drawing spheres in perspective. Any perspective, it's always going to be just a perfect circle. You just get your circle template and plug it in there. You got to sort of know a little bit how to plug it in there. You don't necessarily just do it arbitrarily or just throw it in there anyhow you'd like. And we'll talk about that in the next video, okay? But just another example. So this is a perfect sphere. Well, this is a sphere too, but it's a tennis ball. Forget about the markings for right now. Same thing, anywhere you turn it. Okay, the only thing you will have to worry about is maybe if you're very specific about drawing a tennis ball or a ball with some lettering on it or some markings on it, you'll have to be cognizant of how the markings are shaped, and you'll probably have to design and draw for that. And in that case, you'll probably just use some sort of outside reference to help you get that, to help you draw that accurately. So there you go, all over the place. It's still the same sphere, no matter what. Same sphere, no matter what. Whereas with the box, wherever I move it, even if I keep it, let's say I just keep it just like this. Even when I move it here, you're gonna have to draw something differently. The perspective changes. If I move it here, the perspective is much different, much more different. I move that here, much more different. I move that here, way different. I turn it, different. Okay, so I think you get the point. I think it's crystal clear. All right, so I will, I've gone through that again. I think I've explained the concept in depth, so I will complete the rest of this thing, dealing with circles, spheres, tubes, all that kind of stuff in the next video. All right, see you there.